looking at example 3 here from section 12.2. And go ahead and read the problem. And the data on the right side is what we're going to be using. And we're going to be using this formula that we talked about yesterday. The probability of A given B, let's write this down at the top here, please, is found by taking the probability of both A and B. These are two different things. A/B and A and B are not the same concept. And you divide by the probability of B alone. Okay? The difference between A and B versus A given B is A and B is out of all the probabilities, or all the students surveyed here, how many are fans of the band and going to the concert? That's out of everyone. Whereas the one on the left here that says A/B, that would be, for example, if you just limit it to the kids who are going to the concert, how many are fans? That's a different group, okay? The group on the right top here has more people in it than the group here, all right? The one on the right in the numerator is everybody. Out of everybody, how many are both? The one on the left is just the people going to the concert, okay? So we're going to let A stand for you are going to the concert. Go ahead and write that down there. A will be attend. H will be you're not going to the concert. So you're staying home. That's why I chose the letter H. Okay? F represents you are a fan of this particular band. And we'll say N would be, you're not really a fan of the band. Doesn't necessarily mean you hate them. It just means that you're not, a big fan, buying all their merchandise, following them, and going to their concerts. Now, it is possible that maybe you're not a fan, but you're still going to the concert. Your friends are going, or maybe you're driving, and it's your little sibling wants to go to the concert, and they make you take them, right? Something like that. So maybe you're not a fan, but you're still going. So if you think about it, there are actually 4 different situations in play here that could happen, right? You could be attending the concert, or you could be staying home. So if you could humor me here, go ahead and draw this little diagram that I'm drawing. This is known as a tree diagram. And it just maps out all the options in a probability situation. It's a nice picture of all the options because we can stay nice and organized and make sure that we have all of our bases covered. Okay? So again, the A stands for attending, the H stands for staying home. Along the 2 branches, you put the probability of each of those things happening. So 0.7, or 70% of the students who were surveyed are going to this concert. Pretty big, must be a pretty popular band, whereas 30% not attending. All right? Now from there, we would have 2 more branches coming off of each of these. The A would have 2 branches, and the H would have 2 branches. It's starting to look like the branches of a tree now, hence the name tree diagram. So for these 2 branches, we're either going to say you're attending and you're a fan, or you're attending and you're not a fan. You could be staying home, but still be a fan. Maybe you had to work, maybe you couldn't afford tickets, or something else was scheduled that day, or you could be staying home and not really a fan of the band. So we have the 4 outcomes all mapped out on this tree diagram. On these sets of branches is where your probability of A given, fan given that you're attending the concert would be. That would be on this branch right here. So given that you're on the attending branch, right, that's where the /A comes from, what's the probability of you being a fan of the band? I think that's right here in green. It says 80%. So this branch right there is 80%. And I think we could go right down the line here and get this branch, because if 80% of the students attending the concert are fans of the band, that would mean 20%, or 0.2, are not fans of the band. Okay? This tree diagram, these diagrams are a great strategy for making sure that you have all the options in a situation like this. All right, now let's go down the other way. Let's say you're staying home, right? 30% of the students are staying home. Of them, are any of them fans? Yeah. Out of those students, it says 25% are fans. That number right there is, given that you're not going to the concert, how many are fans? All right. This one up here for 0.2, that would have been, out of the students attending, how many are not fans? That's the 0.2 that you see there. And then there's one more to calculate. And that's going to be, if 25% of the students staying home do like the band, 75% of them, okay, of the students not attending, 0.75. That would be your probability. You're staying home out of the people, no, I did it wrong again. Out of the people staying home, you're not a fan. N/H. This is labeled wrong. This should have been F/H. Sorry about that. Okay, good. So the letter that comes after the slash indicates which initial branch you're on, right? This branch here, attending. This branch here, attending. This branch going down this way, you're staying home, you're staying home. Okay? Now what we're going to calculate using this tree diagram is we're actually going to go back and answer this question in example 3, right? It says, what's the probability that you are attending the concert and you are a fan? To find that probability, it's going to be the number at the very end of the tree. What do I mean by that? If you are attending and you're a fan of the band, you're going to multiply the two numbers along the way to get the probability of attending and a fan. That's going to be 0.56, because 0.8 times 0.7 is 0.56. So 56% of the students who were surveyed, right? 56% of them are both attending and fans. Okay? And you can use the probabilities in a tree diagram to get all of those outcomes. So you can just follow any of the paths. For example, if you wanted to know what's the probability that you are attending the concert and not a fan, you're going to multiply 0.7 times 0.2. You always multiply to get to the end of the branch. So this is going to be probability attending and not a fan. So have your calculator out and ready to go, because we're going to be using it a lot throughout today. Attending and not a fan is going to be 0.7 times 0.2. You might not need to capture that one. It's just 7 times 2 with 2 decimal places. Okay, that's going to be 0.14. So if 100 kids were surveyed, 56 of them would be attending the concert and fans of the band. 14 of them would be attending the concert but not fans of the band. There's 2 more outcomes, right? There are some kids not going, but they still like the band. And to get that, we're going to multiply 0.3 times 0.25. 0.3 times 0.25. These are the students who are probably most disappointed. Had to stay home, even though they are fans of the band, right? Home and fan. 0.3 times 0.25 is 0.075. So if we had 100 kids, I guess there's half a kid in that group, right? 0.075. That would mean 7.5 of those kids are staying home even though they like the band. They are both. Finally, the last of the four options would be, these kids aren't that disappointed. They had to stay home, but they don't really care because they're not really fans of the band anyway. You're going to multiply 0.3 times 0.75 to get that outcome. All right, 0.3 times 0.75 to get that outcome. And that outcome is going to be did you get 225? 225? So that'd be 22.5 of the 100 kids would be staying home and not fans of the band, and they're okay with that. All right, let me zoom out and show you all the options and explain for a moment why this works, okay? So I'm going to go back to 2 pages here, and I'm going to go over to the left, and I want to show you why this works using this formula, okay? If you think about it, this formula has 3 pieces to it. It has the left side, it has the numerator on the right, in green, and it has the denominator on the right in blue. So let's take that very top path, for example. We were looking for the probability of A and F, that you are a fan of the band and going to the concert. And what we did is we took the probability of F slash A equals probability of F and A divided by the probability that you are attending. Okay, that's actually what I set up in my mind, even though I didn't show the work for it. But watch how this would work. This on the left would be the yellow part of this formula up here, right? The left side. And I was telling you that in my tree diagram, that would be the 0.8. 80% of the students who are going to the concert are fans of the band. So that would be a 0.8 equals. The top right, the percentage or the probability that you are both, that was up here in green. And it's right here in green. And that is actually what we didn't know. It's what we were looking for. So in this formula, I would call that X over. The denominator is just the probability of attending, and that was our 0.8, right? That blue denominator right here. I use different letters because it's a different situation. A and B are just generic letters. You can change them to whatever you want. I'm using F for fan, A for attending, H for home, N for not a fan. In any event, this 0.7 right here would have been the probability of attending. Now look at this. Does it make sense when you see a problem like this? If X over 0.7 equals 0.8, you would get X by itself by multiplying both sides, right, by 0.7. So that's where we get the X equals 0.56. All right? 56% of the students are fans of the band and going to the concert.